Hello everyone, welcome to Database Management. This is week 11. For this week, let's focus on the grouping data using aggregate functions. It is about chapter 13, grouping data. We have learned use aggregate function to the entire row of certain interested columns last week, as well as applying aggregate functions to only a subset of rows. It is just a particular group by applying a where condition. This week, we will focus on applying the same aggregate function to different groups of rows of certain interest columns. It is similar to apply a where condition multiple times automatically in one simple query. It will be much easier to show the concept by examples. Okay, let's use our sales order example database to illustrate the concept. Let's use the database and look at what are the tables. And first of all, we're going to use the customer table for the following a few examples. Let's look at it. What is inside the customer table? In the customer table, we have customer ID, name, address, city, state, zip code, etc. And let's look at some sample of the customer table. You see here we have customer ID, name, address, city, state, zip code, etc. And those columns actually provided some nature way to separate customers into different groups. First, let's review the aggregate function with where condition that we did last week. Remember the question that we solved last week include one of the following. Find number of customers in Washington. And we're going to use select count customer ID from customers where customer state is equal to WA. Okay, we write it give us 11, which means there are 11 customers in the state of WA. So we can use the aggregate function and where clause to solve some interesting problem. Now let's solve a more general question. Find the number of customers in each state. In this example, we're trying to segment all the rows by customer state variable. This is called a group by variable. In this case, there are 4 different states, and we can run the above query 4 times with the where condition to be each different state. On the other hand, we can use the following query with group by statement, which automatically segment the rows into 4 different groups and then calculate the aggregate function for each group. Basically, it is select customer state and count customer ID from the customer table and group by customer state. So because we're using the customer state column as the grouping factors, so we're going to include the customer state after the grouping by. You run this query, it's going to return the customer state. There are 4 different, 5, 4, 5. There are 4 different customer state, and this is the number of customers in each state. So we can see that using the group by, the computer is going to automatically separate all the rows into different groups. And the criteria to separate all the rows into different groups is based on the customer state column, which is defined after the group by keywords. So the column after group by is a group identifier, and rows that have the same value in the column after group by will be gathered into a group. So in the customer state column, there are 4 unique values. It can be CA, OR, TX, or WA. And for different customers, they're going to have different customer state. But once we apply the group by customer state, condition, and all the aggregate functions in the select statement will apply automatically to each group. Similarly, we can find the number of customers at each city by using the select customer city, count customer ID from the customer table and group by customer city. That's right. Okay, there are more cities than states in this particular table, and we can see the city name and the number of customers in each city. We can actually use more than one columns after group by to identify the groups. For example, in the customer table, we can use customer state and customer city together after group by. In case there are same city names in different states, we need to distinguish these cities with additional state information. Then we can actually use both customer state and customer city after the group by as the grouping variables. And by using 2 columns, sometimes we can define a much more groups and more interesting groups based on the different combination of state and city. As we can see here, we have the state and city and number of customers. So in this particular one, even there are the same city names at different states, they're going to be separated by different group, because in this particular one, customer state and customer city together is going to define a particular group. In addition to count, we can use other aggregate functions as well with group by. For example, using the order detail table, we can find the total cost for each order. Let's look at it. What is the columns in the order details? The order number, product number, coded price, and quantity ordered. So in this particular one, what we're going to do is we want to find out what is the total cost for each order. So the orders are identified by order number, and there will be multiple rows for each order number. And we need to sum the product of the price and the quantity ordered. The price and quantity ordered will give us basically for each row what is the cost for each individual product. And for each order, quite often there will be more than one number of products ordered, so we need to sum all of them up for all the rows with the same order number. This is a good example to show how we can use group by to find out some numerical summaries. Right? Then we're going to have the order number and the total cost associated with each order. And you can see that there will be one row for each order number. So one rule in using group by is that if you want to include a column in the output that is not a result of aggregate function, in this particular one, it is the order number. It is not associated with any aggregate function. It's just one name. So you must also include it in the group by clause, which means the order number must be included in the group by clause here. So in this particular one, for the order number, for each order number, we return one total cost number. We can also use three different kind of group by variables. In this particular one, we want to return the number of customers at each zip code, as well as return the state and city of that zip code. We're going to need to list, because we want customer state, city, and zip code to be all showed up without any aggregate function. So all those three column names has to be show up in after the group by. And let's write. So we have the state, city, customer, zip code, and number of customers. Even though we know for one zip code there's a unique state and city, but we have to include all three columns after group by if we want all three columns show up, not using any aggregate function. So for the customer ID, that one actually is use aggregate function count. So state, city, and zip code, they're just a standalone. There's no aggregate function was applied to them, so all three has to be show up after group by. In addition to the original information for each column, we can also use expressions on columns used after the group by. For example, in the above example, we can create a new column. We can concatenating customer city, state, city, and zip code into one variable. We call it customer location. And we can also count the number of customers as the number of customers. Then actually two new variables are created. One new variable is created, which is called customer location. It has the state, city, and zip code. And this is example of using expressions on columns actually after the group by clause keywords. Please note you cannot group by the expressions you created in standard SQL. For example, it is technically wrong for the following query in standard SQL, but for MySQL Workbench, it lets you get away with this, but it may not work in other database systems. So to be more specifically to the standard SQL, you should always write your code like that. But in my SQL Workbench, it is a special implementation of SQL, and it actually works fine. But it may not work for other database systems. Okay, that's pretty much all the information that I have, and there's one final example of using group by in a complicated queries. The question is list for each customer and order date what is the total cost. So we want to know for each customer and for each day and how much that customer has been spent for all the orders. And this will include, because we want to use customer's name and we want you to use the order date as well as the total cost. So we have to use three different kind of tables. We're going to use customer table to extract the customer's first and last name, and the orders table to extract the order date. And those two tables, the customer table is interjoined with order table on customer's ID. And it also has to be joined with order detail, because in the order detail, we are going to extract the coded price and quantity ordered information to calculate the total cost for that particular customer ordered on a particular date. And at the end, we need to group by customer's first name, customer last name, and order date. Let's run it. After you run that, it shows customer's full name order date, and the total cost. So this is an example where you can use group by with complicated queries where multiple tables are joined together to provide the needed information. Okay, that's all for the lecture. Now let's come to the homework assignment. For the homework assignment, first read through the chapter 13 of the textbook and do the following exercise based on the sales order database. First, use product vendors table. Find the longest delivered days for each vendor ID. Second, use product vendors table. Find the longest delivered days for each vendor ID and each product number. 3. Use order details in the order table to find for each customer ID what is the total spending amount. That's all for today. See you next time. Bye.